Hello, this is a short notebook to show how we can determine sensitivities of instrument prices to changes in interest rates. I'll skip over this preparatory stuff. Okay, let's say you have an interest rate curve. Well, you might have calculated it in any way. In this case, I'll just bootstrap it over a few rates. I have a 6 months deposit here. I have a strip of forwards, 6 months forwards, and a series of swaps at different maturities. And based on this, I'll just bootstrap a curve using the facilities in the library. So, okay, here we go, and here is the curve that we are getting. Okay, now for simplicity, let's say we're using it to price an interest rate swap. So we take a 12-year swap starting and ending at these dates. Well, these are the various parameters for the fixed leg schedule, the floating leg schedule. We're going to use a 6-month Euribor for the floating rate index, and we are passing it the curve that we have just instantiated for forecast. We instantiate the swap. Let's take 10,000 as notional to make it easier to see the changes, and here we go. This was swap. Now I'm going to set it to pricing engine. Well, to make nowadays we should bootstrap a discount curve separately and pass it to the swap. For simplicity, I'm going to just pass the same curve that we're using for forecasting, and well, I'm going to pass the curve to the discounting engine. I set the engine to the swap, and then I can just ask the swap for its price and print it. So 189. Now I'm going to assume you that you are a sensible person and you want to know how this price is going to change when interest rates change in various ways. Well, you can, for one thing, like you do for any other, like you can do for any other parameter in QuantLib that you input as a quote. If you want the sensitivity to the single rate in the curve, to the single market rate that you use to bootstrap the curve, you can just do it. As I was building the helpers for bootstrapping, I also collected the quotes that we had been used. So for instance, to get the sensitivity to the first quote, the deposit, well, I'll just define a basis point as 10 to minus 4. I'll just take the reference value, I'll just save the reference value of the first quote, and then I'm going to set a new value, which is the reference quote plus 1 basis point, and then I can just ask the swap for its MPV again, and then I'm going to set the curve back to its reference value. If I just do this, okay, I get this change from minus 189.8 to minus 190.1, so it's 1/3 of a basis point, considering that we had 10,000 notional here. We can do it for one single quote, or we can do it for a number of quotes. For instance, we can do the same for all the I can loop over all the quotes, set the value to for all of them to the previous value plus 1 basis point, and ask the swap for its MPV. And then I'm going to set back the value, so I take the current value, I take the basis point back to restore the original value. If I do this, I get this change. So we go from this original value to this one. This works. This is okay. It can get you single sensitivities. It can even get you some kind of stress scenarios, like as you saw, I could raise all the rates. I could also change the curve in more complex ways. But one thing is this can be, well, I won't say difficult, but can be kind of awkward in some cases, because we have a number of rates here which are not homogeneous. So we have deposit rates, forward rates, and swap rates, and a change a similar change in those is going to have a different effect on the zero rates of the curve, and also we can only change the rate that we have as inputs to the curve, so at this particular maturities. So we are kind of constrained to the structure of to the nodes of the curve. Another way we can do the same is to keep the curve as it is and add an additional spread on top of it, which can be done in different ways. For instance, let's try to redo this and add the 1 basis point on top of the whole curve. Well, we can just put the original curve into a new handle and relink the handle that we're using for forecasting and also for discounting in this case to this instance of zero spread return structure. So I'm going to pass the base curve and I'm going to pass a quote containing a spread to apply. So I can do this. I'm going to, so I created this new turn structure which is shifted with respect to the base curve. I link it to the handle and I ask the MPV for its swap, and I get something which is quite similar, well, not quite like it. There is maybe a couple of tenths of basis points difference, but in the same ballpark. Sure, we can't expect it to be the same because here we are adjusting the input rates itself. Here we are adjusting the zero rates of the curve, so it's a different effect. Still, in this way, we can just shift the whole curve, as I said. We can see it more clearly if I increase a bit the spread to 5 basis points and then I plot the original curve and the shifted one. So this is what we get, the original one in a continuous line, and the dashed line is the one shifted. In the same way, which, well, not with this class, which just applies a parallel shift, but with another one, we can apply any kind of stress scenarios. For instance, let's say we want to tilt the curve, so lower, for instance, lower on the short end and higher on the long end. Well, we can just define a series of dates over which we want to apply the different spreads. So for instance, given the reference date of the curve, we take from the spot to, well, let's do it for in this way. So it's up to 20 years. So this is excluded from the last one is excluded. So from now to 20 years at nodes equally spaced of 1 year, which means that we're also going to get nodes that we were missing here, like the 13th or the 22nd. Oh, well, 22nd is not in the range, silly me, but anyway, you see my point. So we get regular dates, we apply a spread which we define like this, so the curve is going to be the same at the 7th year node, and then spread that increases on this end and decreases on this end, and then we just pass the dates and the spread along with the base curve to this class. Well, I apologize on behalf of all the developers for the name that we have chosen. I don't know what came over us at that day. Anyway, base curve, the spreads and the corresponding dates, and here you see that we get the tilt that we were aiming for. So changing the spreads or the dates or whatever, you can get the stress scenario that you're interested in, and at this point you can just ask the swap for its MPV again, and you're going to get the modified value. As I said, not the same as modifying the input rate, still could be a nice trick to have in your toolbox for this kind of scenarios. I hope that was clear enough, despite my rambling. Well, that's all for this one, and thank you.